Other students want it. This is called Chebyshev's theorem, which is a formula that we're going to use. I'll get us through most of this. It is okay, so this is dealing with any set of data, and it says, the theorem says that at least this percentage, so this formula, whatever this formula says, the measurements and distribution lie within K standard deviations. So K is our standard deviation. How many standard deviations away from the mean you are. So this means within K standard deviations. All right, so you were saying that you had a problem with the one like part A that had the percentage. Let's read it real quick. A nationwide test taken by high school sophomores and juniors has 3 sections, each scored on a scale of 20 to 80. In a recent year, the national mean score for the writing section was 47.6. So that's my mean is 47.6, and my standard deviation is 9.7. So based on this information, complete the following statements about the distribution. All right, so the Chebyshev is telling us what percentage of data falls close to the mean. Okay, so on this part A, it says, according to the Chebyshev theorem, at least 36% of the scores lie between blank and blank. All right, so this one's a little bit weird. Actually, I start you off with a hard one, I feel like here, because you got to go backwards. So this formula that we have up here is actually telling us what percentage. So if we're looking at what percentage, we know this is supposed to be equal to, this is going to be equal to the 36%. Okay. So this is going to be equal to 36%. So you actually have to solve for K to figure out how many standard deviations you are away from there. So the first thing you would do is divide by 100, which all that 100 does is going, all it's doing, let me just put 1 here, is going from a percent to a decimal. So if you wanted to just start right here and do 1 minus 1 over K squared equals 0.36, that's fine. The next thing we want to do, if we're solving for K, we are going to subtract 1 from both sides. So now I have negative 1 over K squared equals negative 0.64. But I don't want to deal with that negative. Well, I was trying to think of the easiest way to do this one here. This is actually, I was trying to think if I want to deal with the negative first. Basically, since you have a negative here and a negative here, they become positive. So just so we don't have to deal with it, and you have a negative on each side. I want to rewrite this. This might be where you're getting stuck. So here, this is kind of the hard part when you're solving these. This is like a proportion. You can set it up as 0.64 over 1. And if to do it step by step, you would do this one times 1. 1 times 1 is 1. And then on the other side, you do 0.64 times K squared. So it'd be 0.64 times K squared. Now to get the K squared completely by itself, and I see why you're having trouble with this in the algebra part, you end up with K squared equals 1 over 0.64. So now I'm going to go to the calculator and do that. So 1 divided by 0.64 is 1.5625, and then get the K completely by itself. You do the square root of both sides. So you get K equals 1.25. And it should work out to always be, I would hope they would do that to you. It should work out to be a 1.25 or 1.5 or 1.75. So if you get like crazy decimal, hopefully they don't do that to you. All right. So now that is our K. So that's standard deviations we are away from the mean. So to actually figure out our numbers here, we're still not done. We have to use the mean and the standard deviation now. There's a formula that you may have seen, or you should have seen by now. It's x minus the mean divided by the standard deviation. The z-score is how many standard deviations you are away from the mean. Well, K is telling us how many standard deviations we are away from the mean. So what we actually need to figure out is what data value is 1.25 standard deviations away from the mean. So there's another formula that goes along with this that is written like this. X equals, and all it is this formula rearranged, the mean plus Z times the standard deviation. Okay. So you'll see those two formulas, and that's what we want to do because we know how many standard deviations is away. Okay. It is 1.25 standard deviations away. We know the mean, we know the standard deviation. So what we're going to do is we're going to take the mean plus K times the standard deviation. And when you do that, you should get about 35.5. But then you also got to do the mean minus that, minus 1.25 standard deviations times the standard deviation. And it's 59.7. So that would be the two numbers. So what this is saying is somewhere between, let me write this down first and then I'll say it. So at least 36% of the scores are somewhere between 35.5 to 59.7. And yeah, I definitely see why you didn't like that problem. That being not very fun. I don't know if you part B, I think you said part A was the only one you didn't like, but part B, just to do it real quick. I don't know, is it going to let me? Let me take a screenshot of this and then I can send it to anybody that wants to real quick or needs it. I'll put this on my website. All right, so I screenshot it so I can send that to you if you didn't get it all. That does make sense. I'm glad that makes sense because that problem wasn't as easy as I thought it was going to be. This is the easy one. So for those of you who's like scared of Chebyshevs now, let me just show you how most of the problems work out. All right, so this is like the formula that we're using. So on like part B, it says, according to Chebyshev's theorem, at least what percent of the scores lie between 28.2 and 67? So there, if we go back to the x minus the mean over the standard deviation, we go back to this formula. Z is how many standard deviations you are away, which is the same thing K. So like K and Z kind of mean the same thing. We're talking about how many standard deviations you are away from the mean. So we need to figure out what that is. So our X is our data value. So they say X is called the data value. So we have two different data values here, which it should work out to be the same number. You can use either one you want. So we do 28.2 minus the mean, which is 47.6, which again, I'm getting right here. And the standard deviation is 9.7. So when you do 28.2 minus 47.6 divided by 9.7, you end up with -2. Now do the other one, 67. So 67 minus 47.6 divided by 9.7, you get +2. So that's telling me that K is going to be 2, okay? Because K is 2 standard deviations away from the mean. So now if I plug it into that formula above, 100 minus, oh, not minus, sorry. Forgot the 1. 1 minus 1 over 2 squared, because my K is 2. And then I'm just going to turn this into a percent. So 1 over 2 squared would be 1 over 4. 1 minus 1/4 would be 0.75. 0.75 times 100 would be 75, so 75%. So at least 75% of these people scored somewhere between 28.2 and 67. And if you think back to our last problem, part A, at least 36%, that was a smaller number. It was what? What was our number on the last one? 35, 36 to 60. Okay, so it kind of makes sense that on part A, 36% scored between 36 and 60, but here it's 75% scored somewhere between 28.2 and 67. All right, screenshot that one more time. And again, for those of you who not gotten this far, that's fine. You'll get there eventually. I'm screenshotting these and I'll put them on my website, and I'm recording this. So I have a video for it. And of course, I can go over it again when we get there. Part C and D, I might as well do those real quick. So if it is bell-shaped, you can actually use the empirical rule. That says if I go, so here's like a bell shape. My mean is always in the middle. So this is my mean. It says if I go 1 standard deviation away, so say this is 1, they do 1 standard deviation away, 2 standard deviation away, 3 standard deviation away. On this side, you do -1, -2, -3. The rule here is if I am 1 standard deviation away from the mean, so 1 on each side, 68% of the people would fall between those two. If I'm 2 standard deviations away, it's 95%. If I'm 3 standard deviations away, it's 99.7%. So on the problems that they give us here, which I should have left me more room there. So if we look at like this exact curve that they give us, the mean is 47.6, and the standard deviation is 9.7. The way they get these numbers, so the mean's in the middle, is you add 9.7 as you go to the right. Sorry, I was seeing if I had this already somewhere, so I didn't have to add it. So add 9.7, so this would be 57.3. Add it again, 9.7, would be 67. Add it again, on this side, you're going to subtract it. 47.6 minus 9.7 would be 46.9. And minus 9.7, subtract it again. 37.2. Subtract it again. Minus 9.7. I did not subtract that right, because 47.6 is definitely minus 9.7 is definitely not. I did 0.97. Dang it. 47.6 minus 9.7. 37.9 minus 9.7. 28.2 minus 9.7. 18.5. Okay, so again, this works the same way. This is the data that we're actually looking at. So 68% fell between 37.9 and 57.3. So if it's a bell shape, 68% of the people that took this test scored somewhere between a 37.9 and 57.3. On the 2 standard deviations away, 95% scored somewhere between 98.2 and 67. 3 standard deviations away, I'm running out of room down here. 99.7% of people scored somewhere between 18.5 and 76.7. So this problem asks 28.2 and 67. So 28.2 to 67 would be 2 standard deviations away, right? And then I put this one. That'd be 95%. And then the last question here, I go with it because it's easy since we have this already drawn out. So according to bell-shaped in the empirical rule, 99.7. Well, that means you're 3 standard deviations away here. So my 2 answers are 18.5 and 76.7. So again, if you think about this, the test score was 20 to 80. That's the possible scores. You can score somewhere between 20 and 80. Well, 99.7% of people are going to score somewhere between 18.5 and 76.7.